This is September 4, 2008. This is the Math 8 homework solution. This is the Tuesday one. So the instructions ask us to draw the triangle with the given vertices. Then you're going to multiply each coordinate of the vertex by 3. Then draw the new triangle. How are the two triangles related? We have 4. We have the 3 points, or that represents the vertices, 0, 2, 3, 2, and 3, 0. These are your pre-images vertices, okay? This is your old image. I'm going to apply the scale factor, which is multiplying by 3, okay? So, this is what I did here. I apply the scale factor, which is multiplied by 3. So, look at my first one. 0 times 3. The next one, 2 times 3. The next one, 3 times 3. The next one, 2 times 3. Do you see how I'm multiplying 3 to each value of the vertices? After I multiply, I get the new image. 0 times 3 is 0. 2 times 3 is 6. 3 times 3 is 9. 2 times 3 is 6. 3 times 3 is 9. 0 times 3 is 0. Okay? So after I apply the scale factor, right, I simplify each expression and I got this. This is my new image. This is the image of the vertex. Okay? So, what I have here is I have the graph, right? And I'm going to graph the points, okay? So, because it asks after I got the new vertices, I should graph it and see what happens, okay? So, I'm going to grab paint here, okay? Alright, so but the first one is 0, 2. So, let's do that. It should be red. Let's fill it in here. Alright, so 0, 2. 0 in the x, 2 in the y. That's the first one. The next one, 3, 2. So 3 in the x, 2 in the y. Next one, 3 in the x, 0 in the y. So, good. Right, then I'm going to connect them. It looks like it's a right triangle. Good. Alright. Next. Okay. The new one. 0, 6. So 0 in the x, 6 in the y. Six, 9 in the x, 6 in the y. So 9 in the x, 6 in the y. Yeah, that's okay. Next, 9 in the x, 0 in the y. Okay, now I'm connected. Okay. Alright. Move it back. Alright, it seems like this is all I care about, so I'm just going to grab this piece. Delete that. Okay, let me make the image a little bit smaller. Right, so what can we say? Right, move this out in front of the text here. What can I say? I can say that this is a dilation. Right, what type of dilation? This is a enlargement. This is a enlargement dilation. Okay, and that's it. Right, those are how the two triangles are related. This is a enlargement dilation. Okay, good. Alright, let's do the next one. Okay, I have the pre-image of the vertex. This is what's given. I apply the scale factor, which is multiplied by 3, so everyone should see I'm multiplying each term by 3 here. It's not always 3, right? You're going to see in the next problem how it's not always multiplied by 3, but for the sake of the last two problems, it says multiplied by 3, okay? So I got the next value, right? So negative 1 times 3, negative 3. 1 times 3 is 3. Negative 1 times 3 is negative 3. Negative 2 times 3 is negative 6. 2 times 3 is 6. Negative 2 times 3 is negative 6. Okay? That is how I got the new image. Okay? I call that the vertex, the image vertex, right? The new image. Okay? So once I got that, I'm going to grab the coordinate grid. Okay. Right. Paste the coordinate grid here. We're going to graph this point here. Right. So let's scoot in here so we could see it a little bit better. Let's go red and red. Let's go to the dot. All right. -1, comma 1. -1 in -1 in the x, 1 in the y. Should be that. -1, comma 2. -1, comma 2. And lastly, 2 and -2. Good. Right? There you go. Those are your 3 points. Okay. Connect the lines. Looks again like a right triangle. Try to make that as neat as possible. Alright, now I'm going to graph the new one, which is, I'm going to make that blue. -3, comma 3. -3 in the x, 3 in the y. Okay. -3, -3 in the x, -6 in the y. +6 is right here. -6 is right here. Now I'm going to connect. Alright, great job. Okay. Right. I'm going to grab the image. Right. That looks good here. Right. Delete. Make the image a little bit smaller. Right. So you can see it. Right. I'm going to put it in front of the text so you can see it much better. There you go. What can we say? We would say from red to blue, this is also an enlargement dilation. Okay. This is also a enlargement dilation. Okay, and here the triangle, the red triangle, is becoming bigger because again you're multiplying by 3. It is always an enlargement because the scale factor is greater than the value of 1. All right, next one. I think I should have my right here. Perfect. All right. So what we have here is 13. The vertex of a figure are given. Draw the figure and its image after dilation with the given scale factor. Identify the type of dilation. Here you're given the 3 points for the pre-image, and the k here is equal to 4. That means the scale factor is 4. You're going to apply the scale factor, which is a multiplication by 4 because it says it here. Notice how I multiply 4 to each value. Okay, to each point, x and y, I multiply by 4. After that, I got the new points. Okay, like before, but this time you're just multiplying by 4. Okay, same process. Let's see how it looks like now. All right, this one goes up to a 16, so I had to grab a larger coordinate grid. Okay. All right. Okay. The first one, 4, comma 4. Let's do the pre-image first, right? So, all right, 1, comma 1. So 1, comma 1 here. That is going to be my A value. Let's make that a little bit smaller. That's going to be red. Okay. Okay, that is my A value. Next, 1, comma 4. So 1 in the x, 1 in the x, 4 in the y. I'm going to call that my B value. Alright, next, 3, comma 1. So 3 in here, 1 in the x. I'm going to label that. That's my C. Good. Then I'm going to connect the dots. Looks like it's also right triangle here as well. Good. Then I'm going to go to graph my blue points, which is the vertices after I apply the scale factor. So 4 comma 4. Hopefully I can get this here. 4 in the x, 4 in the y, and that is my new a prime. 4 comma 16, so 4 in the x, 16 in the y, go all the way up here. All right, 1, 2, 3, 4, all the way to 16. Okay, I'll label that. That is my b prime. Okay, and 12 comma 4. So 12 in the x, 4 in the y. There you go. Connect it right here. Good. All right. After I connect it, it's all positive, so I'm just gonna grab the positive parts of the coordinate grid. Right. Put this in front so you can see it. So it says what type of dilation, right? It goes from red to blue, so it says it is a enlargement dilation. Okay, because the red triangle is getting bigger to make the blue triangle. Right? There you go. Okay? But again, you can also say because you multiply by a scale factor of 4. Okay? Or you can say enlargement dilation. Okay? Because the scale factor is greater than 1. Alright? Both explanation would work for this example. Next problem. Let's see, I know my yep, right here. Sweet. Okay. Next problem, 14. Same thing, but it asks us. This time the scale factor here is 0.50, or you can think about this, as 1/2. Okay? Here's your pre-image. I'm going to multiply 1/2 or 0.5 to each value. Right? 0 times 0.5 or 1/2. 2 times 1/2. 6 times 1/2. Right? 2 times 1/2. 6 times 1/2. 4 times 1/2. Alright. So 0 times 1/2, 0. 2 times 1/2 becomes 1. 6 times 1/2 or half of 6 is 3. Half of 2 is 1. Half of 6, 3. Half of 4, 2. Good? All you're doing is multiplying by the scale factor of 0.5 or multiply by 1/2. Same thing. Okay? I have the original pre-image vertex, then I have the images vertex. Okay? I am now going to grab this, right? And I'm gonna graph it. Okay. All right. Let's do the first one together. Okay. 0, comma 2. So 0 in the x, 2 in the y, and I'm gonna label that. That is D. Okay. 6 comma 2. So 6 in the x, 2 in the y, and you're gonna label that E. Good. Then next you are going to do 6 comma 4. So 6 in the X, 4 in the Y, and you're going to label that F. Okay, good. Next, we're going to do the images, right? So 0, comma 1, so 0 in the X, 1, looks like it's right there. Okay. Oop. Call that D prime. 3, comma 1, so 3, comma 1. We're going to call that E prime. Then lastly, 3, comma 2, so 3, comma 2. Right. We're going to call that F prime. Good. All right. So I forgot to connect the red points. So let's connect the blue points first. Okay. Straight line here. Straight line there. Straight line there. Good. Then let's connect the red here, here, and there. Perfect. Okay. All right. Let's just grab the positive end here because that looks like that's all we care about. In front of text, make the image a little bit smaller. What can we say? Right? So we would say this is a reduction, dilation, because the red triangle is getting smaller. Or you can say this is a dilation because the scale factor is less than 1 but greater than 0. Okay? Again, that comes from the definition of a reduction. Okay? This is the definition of a reduction. Right? Less than 1 but greater than 0, while the enlargement, okay, is greater than 1. Okay? Make sure you understand that the scale factor here. Okay? And that's it. There you go. Those are the homework solutions.